A working knowledge of superheat and subcooling is as critical to technicians as our working tools and equipment. Hi, it's Paul again. Measuring superheat and subcooling is essential for optimal performance of a refrigeration system. First, let's look at superheat. As refrigerant enters the evaporator, it's in a liquid state. As heat is added to the liquid, it will turn to a vapor at its boiling point, or saturation temperature. After the refrigerant has boiled to vapor, any temperature of the vapor above the saturation temperature is the superheat. Superheat is then any temperature of a gas above the boiling point for that liquid. The superheat calculation lets you know if the amount of refrigerant flowing into the evaporator is appropriate for the load. If it's too high, then not enough refrigerant is flowing to the evaporator, resulting in poor refrigeration and excess energy use. If the superheat is too low, then too much refrigerant is flowing to the evaporator, meaning liquid is getting back to the compressor and causing damage. Now let's look at subcooling. As refrigerant enters the system's condenser, it's in a vapor state. As heat is removed from the vapor, it will turn to liquid at its saturation condensing temperature. After the vapor has turned to liquid, any temperature of the liquid below this saturation condensing temperature is called subcooling. Because the efficiency of the system is optimized with subcooling, you want to make sure that you have a constant supply of liquid to the evaporator. So it's important that the refrigerant is subcooled to prevent it from turning to gas before it gets there. A smaller amount of refrigerant is required to maintain the desired temperature, which means less work for the compressor. Now that we've gone through the definitions, let's review how you measure them. Subcooling is determined by using the high side manifold gauge to measure the pressure of the condenser. This pressure must then be converted to a liquid saturation temperature using a PT chart or the temperature scales on the gauge. Next, measure the actual liquid line temperature using an accurate temperature probe and subtract it from the liquid saturation temperature. The result is the subcooling value. Conversely, superheat is determined by using the low side gauge to measure the pressure of the evaporator. This pressure must then be converted to a vapor saturation temperature using a PT chart or the temperature scales on the gauge. This temperature is then subtracted from the actual suction line temperature measured using an accurate temperature probe. The result is the superheat value. If you're using a refrigeration system analyzer, simply select the appropriate refrigerant and connect the hoses and thermocouples to the system for an immediate reading. The unit will automatically determine saturation temperatures and calculate the superheat and subcooling. For the most precise readings, make sure your refrigeration system analyzer has elevation compensation settings and accurate temperature probes. That's it for now. Until next time, thanks for watching.